Okay. All right. Hello, everyone. Thank you for joining us. We are here to talk about the power of pre-control. So this webinar is to cover tools and tips from the AESQ process control method group on the pre-control methodology. So we can go next slide. Perfect. And, well, Rebecca, this is showing not as full screen. I have to move around. Don't know if it's just my screen or not. The presentation is going to be started by myself, Steve Hampton. I'm Process Control Manager at PCC Structurals. I'll handle the intro, and then Andrew Stout, the Master Black Belt from Pratt Whitney, Canada, will take us through the content of the presentation. Next slide. So the overview for the webinar, we are recording, and we will distribute the video link once the webinar is done. It will be posted to the AESQ website and also to the LinkedIn website. We will be taking questions during the webinar today using the chat feature. So we'll stay muted. Just feel free to enter in your questions in the chat option or chat box, and then we will circle back around at the end and go through the list of questions with unmuting. And next slide. So why are we doing this webinar? Well, we want to make sure that everyone has an understanding of how pre-control works. So we'll be using some case studies to show advantages and disadvantages and generate some interaction, some thought around this lesser known methodology. Everyone's pretty quick to bring up process capability, airproofing, standard control chart. So this is definitely a powerful tool that is quick to use. And so it's something we want to raise awareness on of when you would use it and how it can help. And also, we want to just make sure everyone understands all the resources available through the reference manual that is produced by the AESQ. And answer any questions. Yep. So the process control reference manual 13006 covers all the process control foundations and tools, and it tells you how to apply these so that we can have consistent use of these processes across AESQ suppliers. And also it's a way that as new techniques and new process control standards come out, then we can update it in a single source for people to reference in the future. This reference manual was developed by a dedicated team of members from the AESQ companies. So subject matter experts and expert practitioners are involved in the group and are who curate the reference manual. Next slide. And so who is this group we talk about? Well, the SMIG group, subject matter interest group, is there to just make sure that we effectively deploy this process control method across the AESQ supply chain, that we have the right experts in this group, and they're accountable for the AS 13100 related requirements and the associated reference manual content. And so make sure that it's up to date and reflect the current knowledge's best practices, and also making sure that there's efficient flow down to the suppliers. And have been approaching that most recently is with a bunch of webinars. And so you can see that we've completed 4. We are on our 5th one today with Power Pre-Control. Next month, we will have a 1-hour process control assessment, and then we have some additional webinars scheduled out in the future that we need to get a date nailed down for, but those are the topics. So And there is also a bunch of training material on the website as well that can be downloaded. Next slide. Here are the members of the SMIG. So these are people that can be reached out to for questions on what's in the reference manual, how to apply. And next slide. And then if you need help, besides the people listed above, we have the AESQ website where you can get those materials I referenced earlier, as well as we have a LinkedIn site as well. So you can go there and post questions and reference the posted materials. The webinars will be posted there as well. All right, and so with that, I will hand it off to Andrew to talk PreControl.
All right, thanks very much, Steve. I'm glad to see we have lots of folks joining in today. Hope everybody's doing well. So we'll start the detail here on PreControl at a high level, really at the process control level. We'll work our way down into details with some examples, options, advice, and even a bit of theory, but not too much theory. Don't want to drive everybody away. So the first thing is, what is PreControl? So basically, it's a way to reduce both product and process risks in order to meet the customer requirements. So that's what it comes down to. It includes both statistical and non-statistical methods to prevent defects from occurring. So we can divide the techniques into the two groups, statistical and non-statistical. And as Steve referred to, we often think of the statistical tools like X-bar and R charts and doing capability analysis as sort of the core. But there are many other methods, many are non-statistical, that can be suitable in different applications and can help us get to the zero defect objectives. So statistical methods include certainly the variable charts as well as attribute ones. And non-statistical, we got a fairly good list of them there. Mistake proofing, which was a big focus of our last webinar. Run charts, which may or may not have some preset limits. The PreControl charts, the focus of today's webinar. Life and usage controls, visual process checks and checklists. The first piece checks and test piece evaluations. So lots of different methods. So, and you can refer back if you want to see any of the past webinars, refer onto the AESQ website, as shown here on the bottom right under events, and then past events. And I'm showing the one for the last webinar, which was done March 8th on non-statistical based process control methods. Okay, next page, please. So non-statistical process control methods. You know, we've likely you're quite familiar with mistake proofing. It's something we should be looking for at every opportunity to try and mistake proof, especially level 1 mistake proofs where you actually prevent an error from happening. Or level 2 is not too bad, where you detect it right away as it's happening before it gets too far. Level 3, not quite so good, but like checklists and things like that, but allow you to catch an error after it's occurred. So that's certainly something that most of you will be familiar with, I'm sure. So other advantages, if the process tends to drift, so you may see a gradual shift, like in the bottom right chart here, where you have perhaps a slow tool wear happening, and you can track the drift over time, going from a low end to the high end. And maybe you want to set some limits on that to make a correction before it goes out of spec. So that can be a good use of non-statistical method. The process data does not readily lend itself to statistical methods for various reasons. Perhaps you don't have the the computing capability in the shop areas, or the type of data being studied doesn't lend itself to, maybe it's a special process that it doesn't not easily measured at various points. So there's other tools that may be applicable. So certainly these non-statistical methods can be easier for the folks who are doing the job on the shop floor, to be easier to understand and accomplish. Can be done on the shop floor. It gives you immediate feedback. There's no waiting for any downstream data analysis, and usually less expensive than the statistical methods. So that can help these days. We're all pressed for money, right? Next slide, please. So when not to use non-statistical methods. First off, process capability metrics may be required by your customer. They may ask for CPK or PPK, and you can't get those from these non-statistical methods readily. Excuse me. If data is needed for the process development, perhaps engineering wants it, or there's process planning needs it to be able to make the improvements. They want the history, they want to see all the details. It might not be, the non-statistical charts may not be applicable. Or if you need to maximize the potential of the process, what does that mean? So just to give you a quick example, this sort of 3 charts on the bottom here showing statistical control charts. So we have lower and upper control limits. And in the first chart on sort of the left end of that, you can see the progress, a lot of variability, and then we make an improvement. There's a new tool changed, new tool put in, different type of tool, and the variability is reduced. And then once we've gained enough history on that, that allows you to reset the control limits to sustain that level of improvement. So on the middle chart of those 3, you can see partway along, we were able to make another improvement. We've done a new locating system, and that allows us to further improve the process. And you can see after a while, we've gained enough history to be able to recalculate the control limits. And normally you'd need more data than what's shown on this chart, but it's just to give you a bit of an example of how it works. So then on the chart on the far right, we're now controlling the process to a much tighter level than we were. So we've maximized the potential of the process. So that's something that we don't get that ability typically with these non-statistical methods. So it's good to know when to use them and when not to use them, when to use something different. Okay, next slide, please. So let's do a little quick comparison in the different charting methods. So we have run charts, PreControl charts, and full statistical control charts. What are they good for? Certainly all 3 are good for collecting data. All 3 are good for monitoring your process. Looking at the middle section, PreControl charts are also pretty good for steering the process and for preventing defects, because they're really focused around the spec limits, your customer requirements, right? Whereas control charts are great for verifying stability of your process, make sure that you have predictability in it, to calculate or verify capability, and to allow you to calculate capability, and then also to maximize the potential of the process. So that's kind of a comparison of the 3. And we have an example down below of a run chart, just a simple run chart with no limits, just to collect data. And on the right, we have a PreControl chart where we have the half of the tolerance shown in the green zone, the middle green zone, centered around the nominal. The remainder of the tolerance is yellow, and then outside of tolerance, beyond the spec limits, would be shown with red. And we'll certainly get more into that on the next in the next sections. Next slide, please. So for the why is it called PreControl? Where does that come from? What's it before control? What's that mean? Well, basically the idea is you get your control limits before you begin production, whereas typically for control charts, for the first application of them, you need to wait for 25 or 30 pieces or 25 or 30 samples of data before you can calculate your control limits, unless you can rely on historic data. So you may need to wait before you can apply a statistical control chart. Whereas these charts, you can do them right away because they're based on the tolerance. You have the tolerance already on your engineering drawing. Where did they come from? They were developed initially by Frank Scatterwaite back in 1953. He was a statistician at a firm called Rath and Strong, and he wanted to develop a simpler method compared to the Shewhart control charts. And if Walter Shewhart developed the original control charts back around 1924, so even further back. So these have been around for a while. They've both been around. When Shewhart was at Western Electric, he came up with the idea of the control charts, and he's typically seen as the father of statistical quality control. That's Shewhart. But Frank is not so well known. He came up with the idea of the PreControl. So we have the three zones. We're going to identify parts as being either green, yellow, or red based on where they are in the spread of the tolerance. Based on a small sample, you're going to decide if you need to stop and either investigate or adjust the process. So in the on the lower chart, you can see we have 2 in a row in the yellow zone to the right of the upper on the lower chart there. So maybe we need to take some action because of that. It looks like, has the process shifted? Maybe there's been a shift, or perhaps the capability has been reduced, and we need to investigate and maybe adjust the process back towards nominal. So it allows a quick response just based on typically two results. If we're talking about individual results, which usually we are in the aerospace business, we do a lot of there's a lot of low volume production, so we need a quick response method based on small samples. So it's good for that. A pretty good process control method to allow defect reduction and scrap reduction. Okay, next slide, please. Now let's have a look at the what's in the reference manual 13006. So this is our process control pyramid, and it shows how the process control methods in the middle build on the foundational activities, things like training, capable measurement systems, maintenance, environment, and standardized methods. So the 9 process control methods build on those to eventually achieve a capable product at the top of the pyramid here. So we're going to focus on PreControl methods, but I'm touching on some of the other ones a little bit. Okay, next slide, please. So where is PreControl in the RM 13006? So we start with it in section 4.1 with the list of the 9 methods shown on the right there. We'll spend a fair bit of time looking at section 5.4. That's where the meat of it is. But it's also touched on in 7.2.1, where we talk about data transformation, handling of non-normal data. In that section, well, it talks about control charts not being, the normal control charts not working so well for non-normal data. So that the PreControl is a nice simple option to use in that case. And then in section 12.3, it mentions that PreControl can be used in the early stages of production. Even if you're intending on using control charts, you might want to start with PreControl because you have your limits right away. Finally, in Appendix C, PreControl is identified as a training topic under the application of control charts. Okay, next slide, please. So this is section 4.1, and I certainly won't read all of this, but just to show you what's in the RM. So to keep a capable process on target when the process has a tendency to move from the nominal value is something that you want to do with this method. So you're starting with a process that is already proven capable. So that's kind of an underlining assumption, or you believe it's capable, or you've proven that it is from past work. And that we'll see how that's important a little later on. So where processes are not sensitive to small changes, it's something that we're looking at as well. If you're concerned with small changes, you may want to use a statistical control chart, a full control chart. When simple operating rules are beneficial, it's good to use this method. When is simple not good? You know, the KISS acronym, of course, it stands for keep it statistically simple. Either that, or some people say keep it simple stout. So anyway, we have warning limits called process control limits, and a reaction to further monitor, investigate, or adjust the process. Okay, and there's some examples identified in the RM. If you're doing a grinding process, you can make adjustments as identified when the PreControl rules are broken, or when they show that adjustment may be needed or investigation. Similarly, making an outside diameter, it can indicate when adjustments are required. Okay, next slide, please. So PreControl can be applied to the process outputs or to the input parameters. That's something else that you can consider. Where does it make sense? The outputs, maybe even the inputs, because it is a nice simple tool. To maintain a capable process centered on target, either centered on the nominal or it could be shifted to a different target value depending on what makes sense. When detection of process special causes are less important. So statistical control charts are used when you want to separate the common or random causes from the special causes that need to be investigated. So that's really one of the big advantages of the statistical control charts. But so PreControl is a simple tool that drives behavior toward on-target thinking. So a little different than the statistical control charts, which can look at the variation more so. How is the variation? Is it because of common causes or because of special causes that require investigation? Okay, next page. So the PreControl chart, as I mentioned earlier, the middle half, typically it's the middle, is identified as green. The remaining half of the tolerance is shown as yellow, and the outside is beyond the tolerance, or the spec limits are shown as red. So that's on the top chart. This is for the two-sided or bilateral tolerance. But it's also going to be used for unilateral tolerances, the one-sided, like flatness and that sort of thing. So in this case, we only have a single green zone, which is half the tolerance, and then the remainder is yellow. Beyond the spec limit is red again. So, and the rules apply in the same way. So it can be used for both. Next slide, please. With PreControl, we start with a qualification, which requires 5 pieces in a row in the green zone. to ensure the process is on target. There are also 3 types or styles of pre-control. We'll mainly focus on the second one, but just so you're aware that you may come across this. The classical method involves a sample of 2 consecutive pieces periodically, perhaps 6 times within a regular adjustment interval, assuming that there is a regular adjustment interval. So this works perhaps with a higher production of something that has very good capability. And we'll talk more about that sort of inspection frequency in a minute, or the sampling. The second method or second style is a 2-stage. And so we make a decision here based on a single inspection, whether or not we need to do a second right away. And we'll go through an example of that in a minute. And the third method is called modified. Basically, it takes the color zones of the pre-control method and applies them to a statistical control chart. So it uses those limits, the statistical control limits, but applies the colored zones of pre-control. So that's something different. You may come across that. So typically, after a process adjustment or tool change or a different operator or change of material, something like that, you need to return to the 5-piece qualification, which is 5 pieces in the green zone before going on. Okay, next slide, please. So there are different opinions on pre-control, whether we should use it or not, where to apply it. So you'll likely come across that. With pre-control methods, there's a risk of adjusting the process perhaps a little more often than is needed. This is much more likely if the process has a poor capability. So that's why we said earlier, we want to apply it where we believe we have good capability, or where we've shown that. So the note here is to determine process capability, always use a statistical control chart and confirm the stability of the process before looking at the capability statistics. Just a reminder. In some cases, such as for minor characteristics, customers may permit an extended period in the green zone on a pre-control chart as evidence of good capability. So it stays within half the tolerance all the time. That's pretty good. Okay, next slide. And in the RM, we also have an example, which I'll quickly run through. So in this case, it's a fuel air bracket, which is shown in the diagram there. And it has, we're going to look at the 0.386 diameter hole, which has a 10 thou tolerance. And we've decided that nominal is our target. So we're going to create this pre-control chart. And so half the tolerance is 5 thou, is a 10 thou tolerance, right? So half the tolerance is 5 thou. So the green zone will be at plus or minus 0.0025, or half of 5 thou on either side of nominal. So 5 thou width. And we're going to use the 2-stage method of pre-control. Next slide, please. So how do we set it up? We're going to start the run, and we see the first part comes out up in the yellow zone, so that's not good. We're going to make an adjustment, bring it in, and then you see the next 5 in a row are all in the green zone, so that meets our qualification requirement. So now we can proceed. So this is a little bit of a tricky thing. We need to understand that typically the method talks about going to a reduced recording of measurements at a rate of about 20%. It doesn't necessarily mean that we're going not to inspect the parts, but we don't have to record them. So that's what the method says, and we'll talk more about that in a minute. So it's important to keep the inspection for acceptance, the inspection sampling separate from this method, which is, we're talking about process control here. So we're not saying you can just automatically jump to checking 1 and 5 parts, right? That's a separate kind of topic. Okay, next slide. So now we're ready to keep going. In this case, we're qualified. We got our 5 in a row in the green zone. So now with this method, we can skip to recording or monitoring, if you will, the 10th piece, which is only 4 pieces away. But just to keep it simple, we want to keep nice round numbers. So we're going to take the 10th piece and record that. And we see that it falls in the green zone, so we can continue with our 20% sampling. So we can go to the 15th piece. We see that's also in the green zone. That's great. We can continue with our process control recording. And we check the 20th piece. Oh, it's up in the yellow zone. And so now we need to check the next one. So we go to the 21st one, and we see it's also in the yellow. So now we think that something has, we suspect something has changed, something has shifted, and it's time to investigate and consider making an adjustment. Okay, and next slide. So basically, there's only 3 simple rules for pre-control. Rule 1, green means go. You stay in the green, you keep going with whatever your methodology is that's agreed upon, whether it's 1 and 5 recording or 100% recording. Rule 2 in the yellow, so in the middle chart on the right, means stop and investigate, consider making an adjustment. And depending on the situation, it could require restarting of the qualification, but that's to be defined in your reaction plan. It should spell out that. And rule 3, if you get 2 measurements in the yellow on both sides, so one in the upper, one in the lower, stop and investigate a potential change in process capability. To have that, there's little chance of that happening unless there has been perhaps a reduction in capability. And you may need to bring in some additional support resources for that, your process planning or maintenance resources, or to investigate further. Okay, and next slide. But now we're going a little bit beyond the reference manual. Let's have a look at some considerations and options. So first of all, I mentioned there was 3 styles of pre-control. The third one was the modified method. It's not really recommended. It has a large false alarm rate. So you may be over investigating when you don't need to, doing more than needed. The pre-control methods described by Breyfogle in his book Implementing Six Sigma, and others as well, talk about taking a sample of 2 consecutive measurements. The classical pre-control method, it says when the 2 are in the yellow, stop. The 2-stage pre-control, when you have the 2 in the yellow, continue, taking up to 3 more measurements. So 3 more consecutive measurements. Continue if the sample, that's the sample of 5 now, if the sample has 3 green, stop if the combined sample has 3 yellow or 1 red. So these are methods that are not documented in the reference manual, but you may see them if you investigate on your own, the pre-control in different textbooks. there are some options there. I find that with these methods, you're talking about more parts. You need more results before you take action and investigate. So I think the method that we've documented in the reference manual is a simpler one of these, and I recommend keeping that. So another consideration. Well, we're running lots of small batches or small lot sizes, right? Typically. And that makes SPC, statistical process control, certainly more challenging in that situation. Now, some people will say, oh, well, we have short runs methods, short runs charts that can help. But they make things a little more complicated, right? They involve coding the data, estimating the target R bar or the target S bar or the target X double bar and so on. So that can be a little bit more tricky to deal with, not as simple as PreControl. There's also group charts that could be used for multiple similar characteristics, like if you have multiple measurements within a part, and where basically you plot the max and min within each group. So that could be good. So these are good things to know about, and they may be applicable. So it's all about understanding the options and understanding the pros and cons kind of each method. There's also deviation from target charts for multiple similar characteristics with the same tolerance that where you can run many different part numbers on the same chart. So that could be helpful as well. Okay, next slide, please. So my recommendations are basically keep it simple. Record all the pieces that are inspected. Use PreControl whenever it's practical. Involve the folks who are doing the job. Get them involved. Get their opinion. Show them some options. Get their input. Track multiple characteristics on one chart where possible. Minimize the number of charts. So with certainly ones with the same tolerance could be put together, if assuming that they used a similar method. If you have the automation capability, consider using % of tolerance, where you can overlay just about anything with different tolerances, where half the tolerance would be green, the remainder would be yellow. So PreControl only with % of tolerance instead of actual size indication. So PreControl can be used for other things like single-sided specifications, even attribute values, good, bad type identify characteristics, or visual characteristics by assigning visual standards for the PreControl lines. So lots of different possibilities to know about and think about when we try and identify the best method to use for our process. Next slide, please. Now, I promised a bit of theory, but only a little bit, so just only one page. So you may have heard of alpha risk and beta risk. Alpha risk being the risk of rejecting a good process. So if your capability, calling it CPK, is at 1, there's basically a 2% risk of overcorrection, or a 98% chance that a correction is needed. So 2% of the time you'll be wasting your time and making a correction for no good reason, but 98% of the time that correction is actually needed, assuming that you have a CPK of 1. So similarly, if the CPK is actually 1.33, the risk is much lower. It's just 0.8% of making an overcorrection. Now, the beta risk is the risk of accepting a rejectable process. Risk of accepting a rejectable process. What's that mean? Well, if both CP and CPK are at 1, there's a 0.23% risk of not making a correction when you should. Not making a correction when you should. All right, so that's the other side, the beta side risk. According to the Bote and Bote in the world-class quality, they use the term enormous statistical power for the PreControl chart method. So that's a good book to read about it if you're interested in learning more. And they certainly highly recommend it, and there are other recommendations. Next slide, please. So I mentioned that you can apply PreControl on process inputs. And here's an actual application that I set up many years ago, actually. And on the chart, it shows 2010, so it might have been 2010. This was actually a laser inspection on machine of cooling holes. And this isn't real data. It's just made up data here on the chart. But the idea was to check an artifact using the on-machine laser to make sure that the machine is still inspecting properly. Right. So we set up a PreControl style chart. In this case, the warning limits were set at basically 2/3 of what was identified as the tolerance, but it's of an artifact, so it's not the artifact doesn't really have an engineering tolerance. So at the edge of the green zone, we have a warning. At the warning, the instructions said that the operator was to get hold of maintenance, to give them a heads up that the machine may be needing maintenance soon. When it hits the edge of between yellow and red, or goes into the red zone, the machine has to stop, and maintenance has to come and do an adjustment. And this is surprisingly, it's so simple that I went down after not being involved in this process for a few years, and I saw that it was still running. So I was quite happy about that. Good to see. And next slide, please. So a little summary of our PreControl advantages and disadvantages. So certainly the ease of use is a big one. No manual or automated calculations. No waiting to set up control limits. A quick signal for when to investigate or act. It's really good for short production runs. It gives you a stoplight style of control to prevent defects. It can be used to hold the gains that you've used or that you've gained from an SPC application. So you don't need to do SPC forever necessarily. Once you've achieved a good capability level, it may make sense to switch to PreControl. Graphical records not necessary, but recommended. So it can be done. The rules are so simple, you don't actually have to have the graphics, but I recommend you have them. With good capability, green means go, whereas control charts may say stop with tighter control limits. Right, so you may end up investigating more than you really need to when you're using statistical control charts. Statistical control limits may cause some confusion especially when you're doing samples, and you can't really compare them with the spec limits. Okay, disadvantages: does not monitor process stability. Not good if the capability is less than 1. Not so good for detecting small process changes. Not very good for process improvement, perhaps. Potential to increase variation by over-adjustment, but it's a pretty small percentage, as we saw in the last slide. May need to develop charts manually or create custom software. So you may not have an easy system software to do this. Okay, and the next slide. Conclusion. So process control is one of our 9 methods shown in the pyramid at the top. And we went over some of the benefits and where it makes sense for steering a process and preventing defects. It's certainly a good tool for that. And I'll hand it back over to Steve to finish us off.
Awesome. Great job, Andrew. Very informative. Let's go to the next slide. So real quick before we get into questions, just a reminder on the future webinars that are coming up. So we just completed the power of PreControl. Now we will have the 1-hour process control assessment on May 16th. So please pre-register for that. Let's go to the next slide, and we are going to go through the questions. So right now it looks like we have 2. So I'll just go backwards. So Jeffrey Wenzel asks, what if the tolerance is non-symmetrical bilateral?
Non-symmetrical bilateral. I'm just looking back. Well, certainly for the unilateral, we have that. Non-symmetrical, well, you can shift, basically it's a target. Your target is not nominal, I think is how would I interpret that. And so the method allows you to customize the chart for whatever makes sense based on your inputs. So you'd have to customize it to suit, but it should still work. I don't know. I need to see an example, I guess, and think about it a little more. It's a good question.
Okay. Stephanie Fisher here we go. Jeffrey said target is nominal, but the tolerance is plus 3 thousandths minus 4 thousandths.
Oh, okay. Well, I think you could still run it. It'd mean perhaps one yellow zone would be smaller, or maybe you compress the size of the green on one side and the size of the yellow because your tolerance is smaller on that side. I think you could still do it with a modified chart. You just modify one side to be smaller than the other to suit your reduced tolerance on one side.
Okay, great. Stephanie Fisher asks, what run size is considered small as far as part quantity?
That's a good question, and I don't have a good answer for that one. Small run size. Well, I mean, we're getting down to run sizes of 1 now. If you're on a 1 part per engine type product, which a lot of our product is. So, and we're moving more and more to that. Maybe making 5 in a row is I would consider a small run.
Okay. And let's see, I'm going to try to do my best to pronounce this here. Swadin, looks like he said, if a controlled process can be stated as capable process in this pre-control method. So I wasn't sure if that was a question or a comment. So Swadin, I don't know if you could add some clarification on the question there.
Well, I think wondering if a process can be identified as capable with this method. Well, if you get enough results in the green zone, like if you see 5 in a row in the green zone, that's a good indication that you're at least CPK of one, right? So it depends what you're trying to hit for your capability as to how many parts you want to see in the green zone.
Okay, and Swadin just replied yes, that was his question. So you're on the same page. Perfect. That looks like all the questions. Oh, here we go. Following up with the question from Jeff, for a tolerance of plus 3,000ths minus 4,000ths, can we take the green zone as plus 1.5 thousandths to minus 2,000ths?
Yes, that's what I would do. Yes, exactly. You got it. So the zones are smaller on one side. If you're trying to keep your target at the well, the nominal value basically is provided, and then go. You have your one side you have 3 thou, and the other side you have 4 thou. So yeah, so one side the zones are smaller.
Perfect. You got 2 thank yous for that one.
Wow. Any other questions?
Right now, that looks like we are good. Okay, yeah, I think we're good. So yeah, so in summary, so all the resources will be available on the AESQ website within a few days, and an email will be sent to all the registrants with a link. So yeah, thank you very much for all your time. Andrew, thank you for an awesome presentation. And thank you for all the interaction with the questions from the participants. And with that, everyone have a great day.
Bye-bye.